go.
Okay.
Because I am not prepared.
Oh, okay.
I'm not prepared.
I'm not prepared either.
So let's rock and roll.
Okay.
So, you press it already?
We're rolling.
All right,
Okay.
cool. So, we're here today with Shankar,
Right.
who has been a lead developer on the C++ teams, particularly working on the IDE
Mhm.
for quite some time.
Mm-hmm.
And so we wanted to come and talk to you about what you've been working on and the history of the IDE and about yourself. How long have you been at Microsoft?
I've been with Microsoft for about 14 years now.
Wow.
Yeah, and 12 of them in C++ group.
Okay.
Yeah.
Always working on the IDE?
No, I've worked on several different components within C++. I've worked on the back end and the linker, the nmake and the profiler for a few years. And then I said, okay, I need to learn Windows programming and I need to do Windows stuff. So I joined IDE group and it's been a blast.
Okay. So now, traditionally with C++, the IDE hasn't really mattered
Right.
for the average systems level developer because C++ largely, except for some UI stuff, but mainly system developers are using C++, where the IDE isn't that matter. They use VI, they use whatever. So how do you get developers really psyched about C++ IDE?
Right. So that was the story a decade ago.
Okay.
It didn't matter. IDE didn't matter, and people did all command line stuff. But over the last 10 years or so, people have been wanting to do more and more things in the IDE. You want to be very productive. It's not like you got to switch to the command line, do something. Oh, there's an error message. Bring up an editor, change the thing, save, hit build again, and go to the command line again. It's been very cumbersome. And to get in, if you look at some of the tools that we have provided, some of the features that we have provided, like the auto completion and the statement completion part, parameter help, quick info. If you hover on an identifier, it'll automatically tell you the type, right? It's a great thing. You don't have to keep browsing. You don't have to open up different files to understand what these things are. You are in the IDE and you hover over an identifier, you get the type. You get to know what it is. You're typing and the definition of that symbol comes in a little window down below. It's a cool thing. Whether you're a systems developer or doing some high-level application, it's a good thing to have some of these things help you when you code.
Absolutely. Now, I can understand for managed code in .NET, in the framework, which is a wonderful base class library as a component of it, with great comments in the code, nicely created, nicely logical inheritance structures, etc.
Right.
What about for unmanaged code? How does this code completion work for some random library you import from someone that wrote, pure C++?
Right. So this is where our thing gets very interesting. You look at native code, which is Windows.h, 75,000 different APIs or something like that. And people could be adding these header files left, right, and center. How do you parse through all these things, understand this information, and bring about autocompletion in less than half a second? If it is more than half a second, people would say, what is this, right? So you want to be able to bring in some of these things in less than half a second. That's where the challenge is. That's why this thing has been so interesting to me, right, all along, to solve some of these problems. And people do evil things with macros. C++ has a lot of macros. You can pound include Windows.h, and you can have pound define Unicode before that. And once you do that, the Windows.h header file looks so very different because its Unicode is defined, and all the APIs have the W at the end, right? Create window W, create file W. It's not an ANSI version anymore, and somebody could delete that line that says pound define Unicode, and all of a sudden it becomes ANSI. Now the header file looks so very different now, right? It's all create file A, create window A, and So how do you understand this information and bring the right set of things to the user? It's very challenging.
So let's talk about that if we can. Let's dig into it a little bit. I mean, when I use Visual Studio, I take for granted how great it is for auto completion, right? Mostly doing C# these days, but it's just wonderful. but I never really think about how it's implemented, because I agree with you. If you're so if we could talk a little bit about how you pulled it off for C++. Are you using an XML file? What do you do when like what happens when I pull in a shared library?
Right. So what we do is we have a modified version of the compiler as a parser working inside the IDE. So you include a library file, and automatically we say, oh, okay, a file has been included, and we send it to the parser thread, which is a background thread, which is a modified version of our front-end compiler, and that parses the file and puts all that information into a file called NCB, which is a data file, which is not an XML format. It's our own binary format, so that you can do fast queries and understand the inheritance structure and things like that. And we make use of that information to reconstruct what the user wants in terms of autocompletion or parameter help or type info. That's how it works.
Excellent. So now is this
in generic terms, in general terms?
That's fine. In general terms, we don't have to get into the IP.
Right.
But is this sort of a programmable layer? Like, is it extensible in any way? Would it need to be?
There is a programmability layer on top. You can call it the code model, and code model is the layer in which tells you the high-level code constructs, classes and member functions and variables and fields and all that stuff. So you can use the code model to either add code or modify an existing code, or change parameters, delete some code, and you can do all those things. And there is a programmable layer. And the good part is this layer is common across all languages.
Okay.
C#, VB, C++, and all the languages who support code model, it's a common layer. But the underlying data, the way we do things are all different in all these languages.
Sure.
Because C++ has its own set of things. I told you about macros, and there are type devs, there are templates, which is not in any other language. So we need to understand templates and namespaces and things like that.
Absolutely. So what are some of the new cool features that you're excited about that you worked on that were just released in WIDBE?
Yeah. So WIDBE, we really released an industrial strength IDE. We have information at your fingertips, symbolic information at your fingertips. You don't need to build, you don't need to do any of those things. You can get all the reference information for a particular identifier immediately while you are typing. You get to know the definition of a symbol right away without having to go anywhere. You can understand the callee information. Who called who. Right? In the past, you had to build the project. You had to build the project, build a file called BSC file, and then figure out, hey, who is the caller for this? How many people are referencing this particular thing, and all that stuff. So in WIDBE, which is Visual Studio 2005, we have all that information at design time. As you are typing code, the information gets built and gets proffered to you. You want to check it out?
Yeah,
I can do a quick demo.
Yeah, let's do it.
Okay. So let me see. I'm going to create a simple Win32 console app.
Okay.
We'll call it demo. And it's a simple console app. It's not using ATL or MFC.
Okay.
And I'm going to hit finish. Okay.
And like all demos, it's going to take us up, but that's fine.
Yeah. So I probably am using a debug version of the Visual Studio.
Sure.
Okay, so if you look at this, you can say class X, right? And you can do XX. And when you hover over this, let me bring up the code definition window. X. Is good, right? And you get the definition of X right there.
Excellent.
Right? Now you can also, you know, C++ languages, you know, people do funky things with overloads and things like that, right? Let's make this void. Right. You can do void F in C. Okay? Let's have a definition for these things. And I can overload this by typing void F char C. Okay?
Yep.
And people do lots of interesting things. Void F, they would say it's a const. Void F, they could say it's volatile. And you could say void F const volatile. Right? Type. So this F tells you, say it gives you the definition automatically. You don't have to go browse something.
Excellent.
And now let's say it's X, let's say it's const. Let's play with the overloads. X dot F12 would call the int guy. X dot F A would call the char guy.
Yeah.
We can say const X CX. Okay, CX dot F. Right. This is going to call the const guy. Volatile CV dot F is going to call the volatile guy, right?
Yep.
And now you can say, hey, I want to get the references. I want to find all references for this F. Okay. And it tells you the references are this F and where the definition is. These are the two references. Although F is there all over the place, it figured out the exact F that matches this particular, the symbol and gives you that particular information.
Excellent.
And this is all done during design time. I didn't build, I didn't save the file. We've been just typing, right?
Yeah.
And we got all this information. And you can also see who calls F, right? We can say call browser, show me the callers graph. Show me who called F, right? So it tells you main is the guy who called F.
Excellent.
Right?
Now, of course, this all becomes really useful when you're using multiple assemblies or libraries
so
that, of course, you haven't created.
That's right. So it's a very simple file, but when you look at C++ projects, or Windows systems code, Windows code,
Sure.
is about 50 million lines of code, and you want to be able to understand who is calling what, because we are generating so many binaries, so many files, and if I go change this particular file, who or all is affected? You want to know that information, and you get that information at your fingertips now. And you can also get the callee information, right? Caller information. We can figure out what are the calls that main makes, right? And these are the different calls that the main function makes.
Excellent.
Right?
Excellent.
And you get that information automatically.
So now, how do I in C++ make a comment that would show up in when a consumer of my class hovered over it, like this, like for the members, right? This class, you need to do this. You need to do that. Does that exist for C++?
Unfortunately, we don't have great support for it yet.
Okay.
We are looking at supporting XML doc comments and as well as regular comments in a nice fashion in an upcoming release.
Upcoming release. Okay.
Yeah, but it's not there yet. Font F, and I don't think you're going to get a whole lot other than, let's see, yeah. Our support is minimal right now.
Sure,
but,
fair enough.
But here are some interesting things, right? Support for comments is limited, but then you could do interesting things like people have several different configurations and things like that. They have debug configurations, retail configurations. There are configurations for x86, different architectures and things like that. People use if something is defined, do this, right? So you can have, let's say, if 0. Let me if out if 0 the code, right? If 0 and if, right? And you see it's grayed out. This code is not there anymore.
Sure.
The compiler is not going to see it. But the IDE parser has its own challenges. We still need to see this code. Because if somebody is trying to rename F, we need to get this F as well, right? So we need to parse through all the different configurations and get all that information so that we can proffer this to the user. And now if you say like, hey, I want the references for F, let's say find references. It caught the first F, which is where I have defined the function, right? And the second F, look at that, it's grayed out. It tells you that it's within an if 0 code, and this could be that F, right? And getting these nitty-gritty details is very interesting and very challenging in the C++ side of things.
Absolutely. So. And if you have something that you want to find through several files, this is very helpful.
Very helpful.
Very helpful.
Very helpful. If you suppose you want to rename something.
Absolutely.
Right? You want to make this F as Charles. Right?
Very cool.
And you need to catch hold of all the relevant Fs. You don't want to change this F. You want to change only that F, right?
Understood. So you have sort of a relational database model going on in the background?
Yeah, it is a database. In fact, that's the database we use for PDB type information, the debug information.
Okay.
It's a common database. It's a common format. We use the same format, but we put different information. PDB puts the debugger needs to have different set of information from what we need.
Understood. So, well, I guess we can't talk about that, but so we're not going to edit that out. We have live editing right now on Channel 9. This is how we edit. So, 14 years on C++ team. You've seen it come a really, really long way. Let's talk a little bit about the future of the IDE. So, another great thing you guys have done is with debugging. I mean, it's amazing the work that you've done in 2005. We've actually had some other C++ people talk about this on the series and the great work in the front and back end compilers. So what excites you most about what's coming up, right, in the Orcus time frame? You guys, you must have some interesting things you can talk about.
Okay, so I don't want to talk about specific features, and
Sure.
if you don't get those features shipping, people would say, hey, I saw that on Channel 9, and it's not there anymore. So in general, I think what we are trying to do for the next several years, people spend a lot of time editing in the design time, right? Editing or browsing or trying to figure out what is what and making changes to the code. And people spend a lot of time building. After making the changes, you hit build, and the whole project gets built. And then most of the times it doesn't work the way you want it to work. So people start debugging, right? So this edit, build, debug cycle is really long. And the vision behind what we're doing is compressing this cycle, bringing the edit, build, debug time as small as possible, so that you get your job done. People are paid what, $100 an hour, $200 an hour, right? The developers. So you want to make them very productive, and that's the fundamental vision behind our work.
Absolutely.
So we'll have features coming along these lines, that would make you really productive. We've considered refactoring for several years. I don't know when that's going to be released, but refactoring code is an important thing, particularly
Absolutely.
for C++, which has a huge legacy code base. You want to be able to clean it up, do interesting things, and morph it to do what you want. And being able to show point-out error messages in the code, being able to detect and probably automatically correct those error messages is all interesting things, and it's a 10-year vision.
Sure. And of course, it's happening synergistically with the evolution of the language itself.
That's right. So
And I know this is very interesting.
both of them are going hand in hand.
Totally. And it's something that I always ask C++ people when we do the interviews with your team is like the advent of .NET and managed code and the ability to write really high level, because C++ is a high level language versus C versus assembly, etc. But
Okay.
how does C++ really fit into this whole managed model? I mean, we talk about productivity,
Yeah.
the actual syntax of a language and the way that a language looks and how much you have to type, and how complex that is, the patterns, must also have something to do with productivity. So when I'm coming into programming, is C++ going to be the language that I learn versus C# on the managed world? Now don't get me wrong, C++ will be around for as long as there's programming, right? There's not going to be a Windows written in C# anytime soon. So let's talk about that. Let's talk about the evolution of your work and the model we have now in programming, which is simplifying high abstraction.
So I really don't want to get into whether it's C# or VB or C++ that you want to use. There are places where C++ is relevant and very important. When it comes to interop, it's you have legacy code and you want to enhance that to add new features. How do you go about doing that? And you don't want to switch to a different language just for that sake. You have a huge code base, you have existing set of people who understand that language. It's very easy for them to get into that, right? And if you look at our model, we have tried to make the native managed disparity as little as possible. Some of the things, it's not our IDE work, it's the work that our team has been, our Visual C++ team has been doing. You take a project, build it, it's native code. You throw a compiler switch /CLR and it's managed code, right? That's the power of the language. You can power of the tools that we are providing to be able to make that transition from one world to the other world. In fact, from while you're developing code, you're not thinking differently. You're not saying, oh, I have to think in terms of managed code, or I have to think in terms of native code. You think in terms of C++, because if you're skilled in C++, you would think in terms of C++, and you would write code that way. Of course, there are certain differences. There are generics and things like that is there in the managed world which you can use in your C++ code. That's something different. And the libraries are different. You have the entire set of .NET frameworks libraries available to you in the managed world. You have MFC in the native world, right? MFC and ATL and things like that. So I think the group's mission has been very interesting and very challenging, that we support both the native customers and the managed customers and the customers in between who are trying to figure out, hey, let me do this in native. Oh, I need to go do this credit card authorization, and I can probably make use of this .NET managed module, and I can use that, pawn import that particular module, and you do your credit card authorization in managed code if you want. So
Sure.
being able to go wherever you want is the power behind this language and this product.
Absolutely. And I was actually interviewing an architect yesterday for Visual Studio Diagnostics,
Uh-huh.
and he was talking about, just in the course of talking about what he's doing,
Mhm.
he was raving about how
Brian
great
Crawford?
it is to write. His name is Mark Seifert or I can't remember the
Okay.
person's name.
All right.
Typical Charles.
All right.
You know. But it's Matt is his name. But he was raving about the fact that he could just do inline. He has to do a lot of interop work, right? Because
Uh-huh.
you're dealing with multiple in the distributed system. You have multiple, types of binaries running, and so he had to figure out how to communicate between them, etc. In his diagnostic work, and was using C++ because he had to do guts work, but could very easily do managed code when he needed to right in line,
Right.
like a ref class and all the great stuff you guys have done.
Right.
So that was cool to see real world use of what you just said.
Right. Right.
Um,
So
very cool.
the IDE work is beyond, it's just not the design time part of it alone. We have a project system which helps you manage big projects, highly scalable projects, tens of thousands of files, millions of lines of code, to be able to keep that all in one solution and be able to manage those type of projects. We did several features along those lines for Whitby. How do you take if you talk about multiple projects, if you want to make changes to these projects, it gets very cumbersome. You don't want to go make change to each and every project one after the other. Suppose you want to turn on exception handling. Let's say you have 20 different projects in your solution. You don't want to go to every project and say, hey, turn on exception handling, and then at the end you might want to go back to where you are, and you don't want to go back and make those changes individually to all these projects. So we have what we call property sheets. You can take a collection of project properties, put them in a property sheet. It's an XML file, and you can apply that property sheet to a collection of projects that you have over multiple solutions. And when you want to make such a fundamental change, all you need to do is go to that base property sheet and change it to whatever you want, right? And it gets applied to all these projects automatically.
Excellent.
So it's a real cool feature, and we talk with ISVs all the time,
Sure.
Or if you look at it's an interesting thing that we have. The top 250 ISVs make 59% of the total money that the ISV market makes. That's about $100 billion.
So now ISV for the customers out there is independent
software vendors.
Okay.
Right. So the top 250 people make most of the money, and those people use C++. So it's very interesting when we and these people have huge projects,
Sure.
and when we, they've been clamoring for a feature like this where they can manage all the projects very nicely, and to be able to do command line builds. You don't want to install IDE in the lab in order to do builds. We have a command line tool called VC build, and you can take vcbuild.exe and a couple of DLLs and build the projects in a very clean environment without having to install Visual Studio. That's a good feature from the project system side.
Absolutely.
We also have support for custom build rules. Suppose you have files of your extension and you want to build these files as part of your project. Let's say .charles extension. You have a bunch of files and you want to have charles.exe run over those files and create object modules or something like that, which gets glommed along with the rest of your project to build the binary, the final executable, or the DLL. You can set a custom build rule now. You can say, hey, from the IDE, you could say, all .charles files, you have to run charles.exe.
Okay.
And
Excellent.
set the rule so that anytime you see a .charles files in your solution, it gets built by that tool and as part of the project system.
Excellent.
That's also an interesting feature.
Totally. Well, you just gave me an interesting idea. I might change my Channel 9 username to charles.exe.
Yeah, sure.
I like
sure.
that. That's good. That's excellent. So let's talk about, bring it back to more of a human level. What's been your favorite thing about working on the C++ team? I mean, your product, and people should know this, and they already do on Channel 9, because we talk about this every time we talk to the C++ team. All of our products are built with your compiler.
Yes.
Every single one.
Yes.
And, most of our products are written in C++. At least the big ones, right? So what has been, your experience with being on this team? What's this team like? Would you recommend people come to the C++ team?
Yeah, absolutely. It's a very hardcore team.
Hardcore.
Yeah. The type of things that we do, the type of challenges that we have are very interesting. We have a huge customer base as well, right? You were just pointing out, most of the products are written in C++. Windows, needs to be built with our compiler, our stuff. So it's a very strategic product, right? So we have a huge history, we have a great future. To be in that center of the world is really, really interesting,
Cool.
Yeah.
Excellent. And, now that you're in the world, the whole IDE space now is really big. And I think with Visual Studio 2005, you guys have been starting to nail the IDE experience for the C++ world. It just seems that way.
Good.
And that's the feedback I've heard. I mean, like I said, I heard this from an architect who's usually writing command line code.
Right.
They're pretty senior developers when you get to an architect level, or whatever, and raving reviews about your product, and that's a great thing. You'll see that on Channel 9, and we'll make sure your team watches that interview. So anyway, I think you guys have done great work, and we'll keep coming back and checking out. We want to check out the evolution of the language too, because I know that Herb Sutter's doing some very interesting things that we can't talk about.
Yes.
But he's still doing some very interesting work in his group.
That's right.
So, excellent. What should we talk about? I mean, you have anything else you want to share with us?
Yeah, I agree. Like with Visual Studio would-be release, we have brought some, good life back into the IDE space, and there are lots of interesting things coming in the future. The would-be release itself, our team has the design time team, project and the build system team, and the debugger team. We all came together to ship a great product. One of the interesting things is, we have stress tests. We stress the IDE enough before we ship, and one of the would-be release criteria was to run IntelliSense stress test on our IDE. And we took Microsoft PowerPoint sources, which has about 5,000 files, put it all in one solution, and ran through the stress test for 750 hours.
Wow.
Which is about 24 hours a day. It's about more than 30 days. Yeah. 30 days of constant typing and making sure that the IntelliSense, the auto-completion drop-down comes up in about 250 milliseconds, and the parameter help shows up, and quick info shows up, all that time, all for the continuous 1 month of typing,
Yeah.
So we did all those things, and we were really proud of this release. 1 month of constant typing is equivalent to, 1 year worth of developer time, right?
Sure.
1 year you would probably type, maybe not type that much, but we made sure that the IDE is rock solid before we shipped, and it was a great release.
Excellent, and it is. So congratulations.
Thank you.
And we'll continue to come back and visit the C++ team to see how the language evolves and the IDE and the whole, everything goes as the world. We don't really know how it's going to end up with managed code, and it's going to be heterogeneous.
Right.
That's my prediction.
Uh-huh.
You're always going to need the right tool for the right job.
Right.
End the story. But very interesting. So thank you for your time.
Thank you.
It was great
Good
to meet
have
you.
you.
Good luck to you.
Thank you.